These days, we hear a lot about topics like machine learning and artificial intelligence. And what's important to recognize is while they're a little bit more complicated than what we're doing, they draw on many of the same techniques. They're looking at distributions and differences and associations and correlations. But some of the key differences between them and what we've talked about so far are just that, number one, computers are doing a lot more of the work. Computers are really just good at churning through lots and lots of data. So for example, while it's difficult for humans to look at a whole bunch of correlations, it's a piece of cake for a computer to do that. As a result, sometimes they're able to identify important features that humans just would never think to look for because the computer's just checking all possibilities rather than trying to go based on logic or theory. Another difference is that when we're using machine learning and artificial intelligence, a model can be trained and updated more quickly and more often. For example, these days with machine learning models, they can be updated many times a day if needed, or at least once a day or once a week or something like that. Where a model that's purely been developed by humans, those used to be updated maybe once a quarter or once a year or something like that, but certainly not many times a day. There just wasn't the time to do that before we had things like machine learning and artificial intelligence. One difficulty with those approaches, though, is it can be hard to describe the models because the computer, in some cases at least, is creating the model itself on the fly all the time. So the model's constantly evolving. It's very hard to describe. And the consequences of that are first that it can hide biases. So, for example, there have been situations where such models have been found to behave differently for men than for women, or for people of color than for white people, and things like that. And it's important to recognize that that's not the fault of the model itself. It's a consequence of the underlying data that was used to create the model. But the tricky thing is that when a model becomes really complex, it becomes very hard to identify a bias like that and deal with it. It can also be hard to act on the results of such a model unless it's happening through purely automated mechanisms. So, in some cases, these types of models would be driving automated mechanisms to, for example, make decisions about whether somebody should or shouldn't get credit or whether a particular transaction was fraudulent or not. So, in those sorts of automated ways, they're very good at making decisions and acting on the results. But if we're trying to get a higher level of strategic insight, it's hard to do that if we don't really understand what's in the model in the first place and why it's behaving the way that it is. Lastly, and this kind of touches on the previous point, when we're using machine learning and artificial intelligence, the gap between when we get an insight from the data and when we can take action can be a fraction of a second. So, for example, this type of approach is used to decide what ad to show you when you're using your smartphone or tablet, and that happens in a fraction of a second just before you see an ad. Whereas previously, when we were doing a lot of data analysis and trying to make strategic decisions, it might have been a situation where we would get the data and not make the decision for weeks or months after having the data.